bit, start off with, what are some of the things you're hoping to find out about the planet?
All right, so we want to understand probably the single most important number we're going to get from Juno is the global water content of Jupiter. How much water is there in Jupiter's atmosphere? And the reason that's important is it tells us a lot about how the planet formed. One of the leading theories for how Jupiter formed is that these icy planetesimal bodies, water ice, collided together, made a big enough core to start having enough gravity to gather in all the other gas and the hydrogen and helium that make up most of the solar system and make up most of Jupiter. So understanding how much water there is tells you a lot about how that worked. Did it happen that way? Did it happen close to the sun where things are warmer, or farther from the sun where things are colder? The amount of material, other material that the water can carry in depends on the temperature. There's lots we'll get just by looking at how much water. So that's one key thing.
Okay.
Another key piece of information is, what is Jupiter's core like? Does it really have a dense core like we expect? And if so, how big is it? The theorists, the ideas range all the way from 3 times the mass of the Earth up to maybe 20 times the mass of the Earth. And of course, that's without any direct evidence of the size of the core, or even for sure if there really is one. So by learning about the core, we'll learn a lot about how Jupiter was made, what's it made out of, and how did it form, and all of that stuff. That's what we're aiming for, is how did Jupiter form, because that tells us how did the solar system form, how do planets form in general, which tells us about, where do we come from.
Well, Steve, I was a follower of Galileo for a long time. That program was just phenomenal, and it showed us so many things about the moons of Jupiter. I mean, like you said, the Jupiter system is like a scale model of the solar system in microcosm. What are you going to do with the moons on this mission?
Basically, we're going to avoid them.
Seriously?
Yeah, so what's going on is some of Jupiter's moons, in particular Europa is really exciting, Ganymede's exciting too,
right.
But potentially maybe could have life. Europa's got this liquid water ocean underneath the ice, we think. So you would hate to get there 20, 30, 40, 50 years from now, whatever, get to Europa, dig down beneath the ice, look in the ocean, find life, and then have to say, I don't know if that's Europan life or contamination from Juno. So we have to make sure that Juno is not going to crash into Europa and contaminate it.
You're going to do a Galileo.
Right, so at the end of our mission, in fact, we are, before the radiation belts have damaged the spacecraft, so
right.
while we still have control, we're going to fire the rockets and crash it into Jupiter. Now, the truth is, if you did nothing, if you just left it alone, we figure there's about a 99% chance, maybe a little better, that that's what would happen anyway. It would burn up in Jupiter's upper atmosphere. 99% chance isn't good enough for NASA. We need to show that we've got 99.99% chance of hitting Jupiter and not hitting Europa. So what we're going to do is, at the end of our year, while we've seen the radiation damage, but we still have good control of the spacecraft and everything's working, fire the rockets, make the thing dive into Jupiter's atmosphere, we'll send back whatever data we can on the way, and we'll burn it up. Obviously, it's my spacecraft, I'd like it to live forever, but the fact is that if we didn't do that, not only would we be taking a risk we don't want to take, but we wouldn't get that much more anyway, because the way our orbit works, it's going to get more and more radiation as time goes on. The last orbit gets a lot more radiation than the first orbit.
Right.
So maybe we could get a few more orbits out of it. We'll know better when we're there, but at some point, it's going to have to disappear anyway. It'd be good to do that in a controlled fashion.